So welcome to problem 3.1. We're looking at problem 3.1 D at the moment. So what we are asked to do is to find the mortality intensity for age 65, where the survival function is given as such. So the probability that the lifetime of a newborn is greater than t is given by 1 minus 110, no, 1 minus t divided by 110 to the 3/4, where t lies between 0 to 110. Okay, so we're asked to find the mortality intensity, and as we noticed in the first video for this problem, here we have the mortality intensity. It's given by the negative of the derivative of the logarithm of the survival function. And this is quite useful. Actually, both this thing and this thing up here are quite useful. They're really good to remember. So remember them, put them in your formula collection or whatever you have, and let's get started with the calculations. Okay, so what we want to do is we want to find the mortality intensity mu of t. So one thing that we probably should notice is it only really makes sense to talk about this on 0 to 110. So for t lying between 0 to 110, and another thing that we actually also kind of notice is it only really makes sense to talk about this for t on the open interval between 0 and 110. Because if t is 110, exactly 110, then the survival function would be 0. And it doesn't really make sense to take the logarithm of 0, does it? So we're looking at the open interval between 0 and 110. Now again, it's not because this is an extremely important detail, but it kind of helps your mind clarify and understand the objects that it's looking at if you sometimes slow down and think a little bit about, well, which interval am I actually looking at? But I mean, for the exam, you could just skip this thing altogether, I guess. But here we're going to say, for t lying in the interval between 0 and 110, we have that mu of t is given by minus the derivative of log of the survival function. And this is equal to minus d to t, and then we'll take log of the survival function, and recall that log of anything, so log of f of anything like that's risen to a power is equal to that power multiplied by the log of that thing. So that means when I take the log of this over here, I can take the 3/4, put them down here, and then I just have the log expression in here. And that's pretty nice, because then that means I don't have to think about the 3/4 when I do my differentiation. So now chain rule, I take the outer function differentiated, that's 1 over the argument, and then the inner function not derived, so that's 1 over 1 minus t over 110, and then I multiply by the inner function differentiated, which is, well, I multiply by 1 over 110 multiplied by minus 1, right? Because the inner function has a minus 1. So this goes out and this goes out. And what I have is I can multiply the 110 into this expression, and I have 3/4 multiplied by 1 over 110 minus t. And that means that if I evaluate my intensity in 65, then it gives me 3/4 multiplied by 110 minus 65. And that is equal to, well, some number that you can figure out on your own. So I'll just put a smiley here. Apparently I didn't calculate this number, but it shouldn't be too hard to get correct. So that was the first exercise. I apologize for the excessive talking, but I think it's necessary in the beginning of the chapter that apart from just learning, apart from just solving the exercise, it's also important to get a kind of feeling and understanding of what's going on, hence the talking. So see you in the next exercise.